Okay, so today we are starting with adding and subtracting our polynomials. In order to add and subtract our polynomials, we need to know what is a polynomial. Does anyone have an idea? Something that what? Say it a little louder. Poly, okay. Poly doesn't mean 8. You're kind of close though. Yes. Poly means many, so 8 would be many. So it's an expression with many terms. So anything that has terms is called a polynomial. Now, what do you think of monomials? What does that mean? So a polynomial with, so a monomial is a more specific polynomial. It's a polynomial with only one term. What do you think a binomial is? A polynomial with 2 terms. What do you think a trinomial is? A polynomial with 3 terms. That's really where we stop. Okay? How do you add and subtract polynomials? So first thing you need to do is you need to eliminate, and I did not spell that right, I'm going to white out. Eliminate the parentheses by, what do we normally do to eliminate parentheses? Distribute. So we're not going to be able to add or subtract our polynomials when our polynomials are still in parentheses. We first need to get rid of the parentheses. Okay? Then we are going to combine our like terms. What makes terms like terms? There's 2 requirements for terms to be alike. Same variable and the variable's exponent. Okay, so like an x and an x squared aren't like terms. They're both x's, but they don't have the same exponent, so they're not like terms. But an x squared and an x squared, those are like terms because they are the same variable and variable's exponent. Okay? So we're going to combine our like terms and eliminate our 0 pairs. All a 0 pair means is if I have like 1x minus 1x. What's 1 minus 1? 0 x's. If you have 0 x's, do you think you need to write that you have 0 x's? Do we need to write everything we don't have? No, we're just going to write the things we do have. Okay, so you're going to eliminate the 0 pairs and combine variables of the same degree. And then we're going to rewrite in standard form. And that means by listing them in descending order. So what that means is like ax squared plus bx plus c. Here I have an x to the 2nd power. Here I have an x, which if it doesn't have an exponent, it's an understood exponent of what? 1. Very good. And here, do I have any x's? No. So that's what it means by putting it in standard form. You always go biggest exponent down to smallest exponent. Okay? And if we have multiple variables, also put it in alphabetical order. So like your x's would come before your y's. Okay, or your A's would come before your B's. I'm going to be less picky about this part. If you have the correct terms, I'm not going to really be upset if they're in the wrong order. Okay, main thing is we need to make sure we have the right terms. Okay, this is just going to help us with later units. Okay, so simplify the following expressions. I have a polynomial plus another polynomial. Again, I can't just start adding them because my first polynomial is in parentheses, My second polynomial is in parentheses. The first step says eliminate the parentheses by distribution. So this first one, is there anything in front of the parentheses to distribute? No. So is there any reason to really even have the parentheses? No. So I don't have to distribute. I'm just going to rewrite it with no parentheses. So 2x squared plus 3x plus 2. My second parentheses, the one below it, has a what in front of it? A plus sign. So I need to distribute that plus. This is where sometimes we make our mistakes. When you distribute a plus, does that make everything positive? What's a positive times a positive? Positive. What's a positive times a negative? Negative. So when you distribute a positive, does it change the sign? No, it keeps whatever the sign was. So a positive times x squared is just a plus x squared. A positive times a negative 5x is just going to be what? Negative 5x. It doesn't change the sign. When you distribute a plus sign, it doesn't change what the original sign was. A positive times a negative 5 is negative 5. Did I get rid of the parentheses? Did I get rid of the parentheses, guys? Yes. So now we're ready to combine our like terms. Now, sometimes you're going to see it like this, where your polynomials are stacked on top of each other. Sometimes you're going to see it like this when it's like in a row. When they're stacked on top of each other, I like it because my like terms are normally already going to be stacked for me. Okay? So I have 2x squares. Do I have another x squared term? Right below it, right? This one doesn't have a coefficient, so it has an understood coefficient of what? 1. So I'm going to put a 1 there. So what's 2x squares plus another x squared? 3x squared. Remember, when you're adding terms, the exponents do not change. When you're adding and subtracting terms, the exponents do not change. Okay? Now I have a plus 3x. Do I have another x term? Right below it, minus 5x. So what's 3 minus 5? Negative 2 what? X. Very good. And then lastly, I have a plus 2 and a minus 5. Negative 3. Are any of these three terms like terms? I have an x squared, an x, and a constant. Are any of these three like terms? No. So we're done. Also, we're in descending order. X squared, x, constant. Biggest exponent down to not even having a variable. So that's my answer. So guys, today's lesson is super similar to what we've already done. Have we already distributed before? Yeah, you did that last year. Do you know how to combine like terms? Yeah, you did that last year. You've done it this year. Okay, so all of this stuff today is really a review of things we've done before. Okay? The only thing we're really adding is now just having the whole polynomial in parentheses. Okay? Okay, next one. Is there anything in front of the parentheses to distribute on my top polynomial? No, so just rewrite it without the parentheses. 2x squared plus x minus 4. When you distribute a negative or a minus, what does that do? Changes all the signs to the opposite. A negative or a minus means the opposite. So what's a negative times x squared? Negative x squared. What's a negative times a negative 4x? Plus 4x. And what's a negative times positive 1? Negative 1. Okay, so we got rid of the parentheses, so now we're ready to combine our like terms. Again, since they're stacked on top of each other, our like terms are stacked on top of each other. I have an x squared term minus an x squared. The x squared doesn't have a coefficient, so it has an understood coefficient of 1. What's 2 minus 1? 1. Do you have to put a coefficient of 1? No, so I'm just going to put x squared. Would it be wrong if you put 1x squared? No, but this is more simplified. This x doesn't have a coefficient, so I'm going to put a what there? A 1 in front, plus 4x. So plus 5x, because remember, our terms are separated by addition and subtraction signs, so you have to have a plus or minus in between each of your terms. And then I have a minus 4, minus 1. Minus 5, negative 5. Very good. Do I have any more like terms? Nope. Are we in order from big exponent down to no exponents? Yep. There we go. Yes, ma'am.
Every time it's like stacked on top of each other, is it always going to be lined up?
So almost always it's going to be lined up. Sometimes, like let's say this top one has an x squared x constant. Let's say this bottom one just had an x squared and a constant. So it'd be in the correct order, but maybe it's missing a term. So whenever I rewrote it after distributing and getting rid of the parentheses, I would line up the x squared under the x squared, and then when I distribute it to the constant, I would line that up with the constant. This would just have a blank here then. Okay? It's going to be in order. It's going to be given to you in order, but it might be missing terms. Good? Guys, it's not super common to see them stacked on top of each other. Okay? We're going to see it more like this where it's in a line. Okay? So if you're color coding, it'd be a good idea to color code these or circle, box, all of them. Okay? Same process, even though they're not stacked on top of each other. We need to get rid of the parentheses first. Is there anything in front of the parentheses to distribute? No. Guys, let's make sure we're all paying attention. So I rewrote my first parenthesis without the parentheses. Just rewrote the polynomial exactly as is, just no parentheses. Now the next parenthesis has what in front of it? A plus. Again, when you distribute a plus, does it change signs? So my 6x squared y squared is still just going to stay positive. Plus 6x squared y squared. And then a plus times a plus is still plus 8xy. A plus times a plus is plus 3xy squared. Again, you cannot skip this step. This is not a super difficult concept. However, if you try to add and subtract the terms before you get rid of the parentheses, you're going to get the wrong answer most of the time. Okay? So don't be lazy. Don't skip that step. Now we're going to try to identify our like terms. That first term has two variables, an x squared, y squared. So I need to find another term that has an x squared and a y squared. Do I have another term that's an x squared, y squared? What? Perfect. Plus 6x squared, y squared. Now, the way you know what operation to do is by what's in front of it. This is a positive 4. What's in front of the 6? So 4 plus 6 is 10. Don't change the variable's exponents. Remember, when you add and subtract, the variable's exponents never change. Next, I'm going to circle. And notice when I'm circling my term, I'm circling the operation sign in front of it. So next I have a plus 5xy. Do I have another xy term? Plus 8xy. Make sure you include the operation sign in front because that lets you know what we're going to do to the coefficients. Positive 5 plus 8. Positive 13. So plus 13 xy. Next, I'm going to box. Negative 3xy squared. Do I have another xy squared term? Plus 3xy squared. So it's negative 3 plus 3. 0. They cancel each other out, so I don't have to write that term at all. They're gone. Are these like terms? They both have an x and both have a y. They don't have the same exponents. Remember, there's 2 requirements, same variable and same variable's exponents. So we're done. Thumbs, how are we feeling about these? Easy way to go back into school after a nice long break of probably not doing any math. Okay, there's a reason we did that. Starting off, baby steps. Okay, next one. Do I have anything in front of the parentheses to distribute? Nope. Drop down your 11m squared plus 2m minus 11. Do I have anything in front of the second parenthesis? A minus or a subtraction. So a negative times 5m squared is? Perfect. What's a negative times a negative 6m? Plus 6m, because remember, when you distribute a negative, it changes the sign. So a negative times a negative 17? Plus 17. So we did our first step correctly. Get rid of the parentheses. Next, combine like terms. I have an m squared. Is there another m squared term? So what's 11 minus 5? 6m squared. Then I have plus 2m and plus 6m. Plus 8m. And then we have negative 11 plus 17 plus 6. Are any of those like terms? No. Are we in the correct order? Yes, we are done. Okay, I want y'all to try number 5 on your own. Try number 5 on your own. Okay, so I got 3a squared plus 7ab plus 5b squared. Thumbs? Good? Kind of okay? I didn't even do it. Didn't know where to start. Do we have questions? If you got something wrong, ask a question. There's no like term with my 3a squared. Drop it down. My ab's, 3 plus 4 is 7. And then I have my b squares. This minus b squares is a minus 1. So 6 minus 1 is 5. Good? Now this is in the correct form because a's come before b's. Okay? Okay, we're going to do, I think, one more of these, and then they're going to look a little different. Okay, rewrite without the, yes, sir.
So if you didn't have a like term, you just drop it down.
Yep. That's what Lexi was asking at the beginning, like, will they always be lined up or whatever? And I said sometimes, yes, when they're stacked, they'll always be lined up, but you could be missing a term. It's okay for terms not to have another like term to combine with it. Okay, anything in front to distribute? Nope, rewrite it without the parentheses. What's in front to distribute? So what's a negative times 2y squared? Negative 2y squared. What's a negative times a negative 4y? Plus 4y. And what's a negative times a positive 3? Negative 3. Very good. Let's look at our like terms. I have a y squared and a y squared. What's 5 minus 2? 3 y squared. Then I have a plus 7 and a plus 4. What's positive 7 plus 4? Plus 11y. And then I have a plus 8 and a minus 3. Plus 5. Are any of those like terms? No. So we are done. Good? Okay, same thing, now they just look slightly different. Some of them look slightly different. Some still look the same. Okay, this first one, notice how I don't have any parentheses at the front. But do I have parentheses then? So let's rewrite the whole thing without parentheses, okay? So I'm going to drop down my 3x squared minus x squared. Then I get to my parentheses. What's in front of the parentheses? Plus. So what's a positive times 4? Plus 4. What's a positive times negative 4x? Negative 4x. Great job. What's a positive times positive 2x squared? Plus 2x squared. Great job. So what's a positive times 2x? Because now the next parenthesis has a plus in front of it. So what's a positive times 2x? Plus 2x. So did I get rid of all my parentheses? Yeah, so this is the same thing. It just looked a little uglier at the beginning. Okay? But we followed the same process. Now let's look at our like terms. X squared. Do I now have another x squared term? What? Do I have another x squared term? Negative x squared. What's the coefficient of negative x squared? So I'm going to put a 1 there. So this time we have more than just 2 like terms. Here we had 3 like terms. Is that okay? Yeah. What's 3 minus 1? 2 plus 2. So this is 4x squared. Which one do you think I should go to next, the 4 or the minus 4x, if we're technically wanting it to be in correct order? The minus 4x. We're going to go there next. So is there a like term with minus 4x? Plus 2x. Do you see why it's a good idea to circle, underline, box things? It's going to help you know which terms you've already combined and which ones you haven't. Okay, make sure you don't forget any. So what's negative 4x plus 2x? Negative 2x. So what's my only term left? Plus 4. Is there a like term with plus 4? No, that's the only constant. Constants always go at the end. Are these 2 like terms? No, because they don't have the same exponent. Done. How do we feel about that one? Some tricky things, right? But still the same process, okay? We had more than just 2 like terms that we had to combine, and we had one that didn't have any like terms, but that's okay, same process. And also, it was in a weird order, wasn't it? This one, from being constant, x squared, that's in a weird order. Okay, next one. This looks more like the ones we did on the front, but it's also kind of in a weird order, right? Anything in front to distribute to the first parenthesis? No. What's in front of the second parenthesis to distribute? So what's a negative times 7? What's a negative times 2x squared? Okay. Which term should we really start with, guys, if we want it in the correct order? The x squared. Good job. The negative 3x squared. Is there another like term with that? So what's negative 3 minus 2? Negative 5, and what's your variable? X squared. Very good. Now let's go on to our x term. Is there another x term? No, so there's nothing to combine it with, so I'm just going to drop down plus x. Why am I putting a plus in front of the x even though there's not a plus here? Because x is positive, okay? And you have to have a plus or a minus sign separating your terms. Okay, and then I have a plus 1. Do I have another constant? Remember, what's a constant, guys? Number without a variable. Good job. What's positive 1 minus 7? Negative 6. Great job. Is that in the correct order? Yep. Do we think we can do the next one on our own? I will say it's just kind of in a weird order, but try it. Okay, let's see how we did. I got negative 7r squared plus 12r minus 8. How'd we do? Good. Do we have any questions? If we got it wrong, do we see a mistake? What was our mistake? No questions? Okay. Are we good skipping the next one? I think we are. No? Well, we still have more practice. We're not done. Definitely not done. But I want to go to one that has a fraction. How many of us missed fractions over the Christmas break? No one? I don't believe y'all. Okay, let's look at number 11. Same process, guys. Is the 9q squared, are there parentheses around it? No, just drop it down. What's in front of the parentheses here? Negative 2/3. So negative 2/3 times 3. Let's all go to our calculator to help us remember how to do fractions on our calculator. Let's all go to our calculator because, again, we haven't used them in like 3 weeks. Okay, so I'm going to do negative. How do you put the fraction in? Alpha, y equals enter. 2/3, and then arrow over, times what? 3. And I get negative 2. And it has what variable? Q, so negative 2q. Now let's talk, some of us might actually want to know why that's negative 2q. Remember, when you have a fraction times a whole number, multiply the numerator by the whole number. So what's 2 times 3? And then divide by the denominator. What's 6 divided by 3? 2. That's why it's 2. Okay? And a negative times a positive is negative. Okay, now let's do negative 2/3 times negative 7. Negative alpha y equals enter. 2/3 times negative 7. And we get a fraction. Keep it as a fraction. It's positive, so what should go in front of that term? Plus sign. Very good. So plus 14/3. Is it okay to have a fraction in the problem? Yes, fractions exist, guys. Do I distribute the negative 2/3 to the 5q squared? No, because the 5q squared is not in parentheses. So just drop down your plus 5q squared. Okay, now we're going to look at our like terms. Do I have any like terms here? What are they? 9q squared plus 5q squared. So what's 9 plus 5? 14. So I have 14q squared. Next I have my minus 2q. Is there a like term with that minus 2q? No, so it's just minus 2q. And then lastly I have my plus 14/3. Do I have a like term with plus 14/3? Are any of these like terms? Nope. Done. Okay, I want y'all to try number 12 on your own. Try number 12 on your own. Okay, so I got x minus 1. Notice how I did also write it as 1x minus 1. Would that be acceptable? Yeah, but this is technically more simplified. Okay, we good? Okay, now we are going to go on to some application problems. Okay, represent the perimeter. So we need to know some vocabulary in order to do these. What does perimeter mean? Add all sides. So if all the sides aren't labeled, can you find the perimeter? You can, but first you have to do what to all the sides? You have to label all the sides. Biggest thing we make mistakes of. We see find the perimeter of this. We have these two sides labeled. We just add these two together and then we're done. Do you think that would be an answer choice if this was a multiple choice question? Definitely. Would that be the correct answer? No, because you have to add all the sides. Only 2 of my sides are labeled. So can I label this bottom side? What's this bottom side? And some of us are a little lazy and we like to just do things in our head and like not actually label the picture. I promise you, please label the pictures. If this side's n squared, what's this side? Now, I will say I'm okay if you don't write it out as one long polynomial. We have all of our terms here. We're good at underline, boxing, squaring stuff. So let's underline our like terms. I have an n squared here. What's its coefficient? That's the exponent. What's the coefficient? 1. I have an n squared here. What's its coefficient? 1. I have an n squared here. What's its coefficient? I have an n squared here. What's its coefficient? 1. So 1 plus 1 plus 1 plus 1. 4n squared. Okay, now let's move on to our n's. I have a plus 5n. Do I have another n term? What is it? Plus 5n. Do I have another n term? No. So it's 5n plus 5n. So plus 10n, because remember you have to have a plus or minus to separate your terms. And then I have a plus 1. Do I have another constant? Plus 1. So what's 1 plus 1? Did I add all of the terms? Did I underline, box, circle all of my terms, meaning I used them? Yeah. Am I in the correct order? Yes. Are any of these like terms? No. So we are done. Good? Okay, next one. The triangle, all the sides need to be labeled to find the perimeter. Okay? So, I have an x squared term. Do I have another x squared term? Plus 4x squared. So it's 2 plus 4. So 6x squared. Then I have a 4x term. Do I have another x term? And it's a positive. So what's 4 plus 9? So plus 13x. And then I have a constant of 8 plus 8. Do I have another constant? Minus 2. So it's 8 minus 2. So plus 6. We good? We're in the correct order. None of these are like terms. And we are done for the day, guys.